Assalamu alaikum students. Today we are gonna read about electric current in conductors. Now wherever that in case of the conductors, we are having what? We are having as free carriers as the electrons. And we should have one another knowledge that in case of the conductors, the atoms and molecules of which these very conductors are made up of are closely packed. And the valence electrons of the atoms are not attached firmly to the nucleus. That is, there are the free electrons. And these free electrons, or the valence electrons, are free to move throughout the volume of this very conductor or solid, hence as we call as the free electron. So if we are having this as a free electron, in absence of electron, it will go like this, then this, like this, to crossed out. So it will go then like this or this, whatsoever. It can have zigzag motions. So what I mean to say, that in absence of this very electric field, once will take conductor, there are motions of the free electrons, and these are zigzag motions. They are having thermal speed of the order of 10 raised power the thermal speed. The electrons, the free electrons have thermal speed, thermal speed of order 10 raised power 5 to 10 raised power 7 meter per second. This is the speed of electron in absence of electric field or at room temperature. These random motions of an electron in the conductor, as they are shown here. Now, the flow of electrons is so oriented. The flow of electrons is so oriented that the number of electrons crossing through the cross section, if I have chosen this as a cross section, now the electrons are moving such that the in the given cross section of conductor, in a particular direction there is no net flow. That means whatever are the electrons crossing through the cross section of conductor in one direction, the same number of electrons are crossing from one side to another side. That is, there is no net flow. There is no net flow of electron through a given cross section of conductor. Hence you can say the flow of electron, the net flow of electron is zero. Net flow of electron is zero at room temperature. Because if you are having some amount of electrons, those are having the thermal speeds of the order of 10 raised power 5 to 10 raised power 6, of the order of 10 raised power 5 to 10 raised power 6 meter per second, and they are crossing this very section, this very cross section. Some electrons are crossing from this very side to this. So as a result, no net flow. Net flow of electron is zero at room temperature. Hence, as a result of which electric current is zero. That is, electric current is zero. Now once we are going to apply electric field, that is, we are going to say this is the same conductor. Now we are going to apply what? Positive and negative. We are going to apply a battery or cell. This is connected to positive, this is connected to what? Negative. This is positive and this is negative. Now the electrons are going to cross this very section. They are going to cross. This electron is going to go like this, like whatsoever. They are having the motions. And one is they are crossing. So why they are crossing now? Because now a potential difference is applied. Now an electric field is applied. One is an electric field is set up across the ends of the conductor. The free electrons in the conductor experience, now this very electron experience a force, and that very force is equal to what? Minus times E into E. From the definition of electric field, as we know, electric field is equal to force by charge. Now we are having the force is equal to here charge into electric field, which we are having, which we have applied. The electric field direction is this, from positive to negative. This is the direction of electric field, but the electrons are moving opposite to it. So thus free electrons in the solid conductor are accelerated. Thus electrons are accelerated in opposite direction to electric field. So once electric field is applied, there is movement of electrons, and those very electrons are having an acceleration of they are having a force on them, a force exerted, and that force is F is equal to minus E into E. So if now we are going to remove this very battery, the same thing will happen. There will not be any movement of electrons. The current will stop immediately. So it is only on the application of this very battery or cell, there is what? There is movement of the electrons in a particular direction. Now there is the important concept of that is called as the drift velocity. What is drift velocity? Drift. So actually, as now we have applied the electric field and electrons are moving. In absence of electric field, they are having a thermal speed which we have already pasted 10 is power 5 to 10 is power 6 meters per second. But as there is no net flow, the velocities are so oriented that there is no net flow of electron in a particular direction. So if we will take the average velocity in absence of electric field, if you are having u1 plus u2 plus u3 plus dash 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 un by n, if we are having n number of electrons, they are having these three types of velocity, it simply comes out to be zero. But when in absence of absence of electric field. So now once the electric field is applied, there is movement of these very electrons. The electrons move from one side to another side in a particular direction. But now once the electric field is applied, we are of the opinion that they should have more and more velocity, but their velocity is very, very small. They carry a small velocity. And that very velocity is called as the drift velocity or drift speed. Drift speed is defined as the average speed. It is the average speed with which electrons, free electrons, I will say, free electrons average speed with which free electrons in a conductor get drifted in a direction opposite to electric field. Average speed with which free electrons in the conductor get drifted in a direction opposite to electric field is known as drift speed or drift velocity. So this is the very small speed. Why it is very small speed? Because when the electrons move, they get collided now. They get collided with the constituents, the atoms, the ions which are present in this very material. They get collisions time and again. That is why the velocity gets decreased. They get only a small velocity, and which velocity is called as drift. They get accelerated. The electrons get accelerated, but they get accelerated for a small time. Once this electron gets acceleration, now it is going to move with that very acceleration, but it soon gets collided with this, and after the collision with this, it gets again accelerated, but soon it gets collided with another atom present here, or ion present here, everywhere in the atom. So that is why it's having only very small velocity known as drift velocity. This is all for today. Tomorrow I will be with another lecture. Till then, Allah Hafiz.